graphing a linear inequality in two variables. Now, in the previous example, I gave you a solution and you had to check it, but the question is, well, how do you find that solution? So in order to find the solutions, we're going to graph them. Step 1, graph the boundary line for the inequality. Use a dashed line for a less than or a greater than. Okay, dashed line, this is important. Put it in a box, please. Use a solid line for a less than or equal to or a greater than or equal to. So it's kind of like when we use an open dot versus a closed dot. If it's less than or greater than, you would use an open dot. If it has the equal to sign, you use the closed dot. So here we're using a dashed line, here we're using a solid line. Step 2, test a point that is not on the boundary line to determine whether it is a solution of the inequality. Step 3, when the test point is a solution, shade the half plane that contains the point. When the test point is not a solution, shade the half plane that does not contain the point. So let's take a look at that. Example 2, graph the inequality. Letter A, y is greater than -1. Now, this is simply y is greater than -1, so it doesn't have an x, so in this case we either have a vertical line or a horizontal line. The way I typically remember is I say, okay, y has to be -1, so x could be anything I want. So if x is 1, y is -1. If x is 4, y is -1. If x is if x is -3, y is -1. So if I kind of map out all the places where y, right here, is -1, that's giving me a horizontal line. Now, before I draw my line, I'm going to go look at my inequality sign, which is strictly greater than. That means when I draw this, I'm going to draw a dashed line because I'm not actually equal to the -1. I'm strictly greater than. Now, if -1 is sitting right there at that horizontal line, and let's say y has to be greater than -1, would you assume greater than is above the line or below the line? And my assumption, because it said greater than, would be above the line. So we're going to go pick a test point, and I'm going to pick any point that is above that line. So let's say y is 2. That is my test point. So if y is 2, I'm going to substitute 2 is greater than -1. Is that true? Is 2 greater than -1? That's true, which means the point 2, y equals 2, is a solution. So we're going to shade everything above that line. Okay, which tells me anything up there is a solution. So if I say y is 0, 0 is greater than -1, yes. If I say y is 3, 3 is greater than -1, yes. If I say y is 5, 5 is greater than -1, yes. Now, below the line, -2, -2 is greater than -1, no, it's not. False. Hence, anything down here, not a solution. Anything up here, yes, a solution. Let's try again. Letter B. X is less than or equal to -4. Again, this does not have the two variables, so it's either vertical or horizontal. Given that the last one was horizontal, I'm probably assuming this one's vertical. But x is -4, so x is -4. X is -4, y is 3, x is -4, y is -3, etc. And it says less than or equal to. So when I connect this time, we're doing a solid line. Now, the question becomes, do we shade the left or do we shade the right? So let's think about this. We need a test point. This says x is less than -4. So if it was less than -4, would we assume that it's to the left of the line or to the right of the line? I would assume it's to the left of the line, but let's say I picked a test point of 0. If my test point is 0 and I substitute in 0 is less than or equal to -4, is 0 less than -4? That's false. So because this is false, I do not shade over here. That's not true, which means I would shade over here. This is the true part, anything over here. So if x is -5, -5 is less than -4. Yes, that's true. If x is -10, -10 is less than -4. Yes, that's true, etc. Letter C, x plus y is less than or equal to -4. Now, this one has two variables, so our line is not going to be vertical or horizontal. It's going to have some slant to it. Option 1, we can convert this to slope-intercept form. Option 2, we could find the x and y intercepts. For this one, personally, I'm going to just convert it to slope-intercept form. So I'm going to subtract x from both sides. So that's going to leave me with y is less than or equal to -x minus 4. Then I'm going to have a y-intercept of -4. And I'm going to have a slope of -1, so down 1 over 1. Or I could go up 1 over 1, up 1 over 1, etc. And then when I graph my line, keep in mind it's either dotted or solid. So in this case, because I have the equal to sign, it's going to be solid. Now, I kind of take my pencil and I lay it on that line. And you can kind of think of like if you're on that line, you can go like up from the line, you could go kind of like down from the line. If this says y is less than or equal to, would we assume we kind of go like down from the line, or would we kind of go like up from the line? And because it says less than, I'm going to assume we kind of go like down from the line. So I'm going to go over here and I'm going to pick a point that's kind of like, in my opinion, like below the line. And this point is at -3, -3. And I'm going to test that. So -3 less than or equal to -3, okay, because it's like -x minus 4. So -3 is less than or equal to negative is 3 minus 4. -3 is less than or equal to -1. So let's think about that. Is -3 smaller than -1? That is true, which means we shade this side. Which means anything down here is true. If I were to pick the point -2, -5, that is a solution. If I were to pick the point -5, -2, that is a solution. Any point where I shaded in red or any point on the line, -3, -1, that is a solution to that inequality. Letter D. X minus 2y is less than 0. Okay, once again, I'm going to convert this so that I can graph it. I'm going to start by subtracting x. That's going to leave me with -2y is less than -x plus 0, which you can or cannot write. Now, this time I'm going to divide by -2. I'm going to divide by -2. Do we remember what happens to the inequality sign when you divide by a negative and you have to switch it? So y is greater than, negative divided by a negative is a 1/2 positive x. So y is greater than 1/2 x. The y-intercept here still plus 0. And then slope rise 1, run 2, rise 1, run 2, or we could go the other way. And then dotted or solid line. This time we're dealing with strictly, if I'm looking at this dude, a greater than sign. So I'm going to make this dotted. Now, if I'm looking at the guy I have in the box, and that's usually the guy I look at because it says y is greater than, do you think we would want to go like above the line or below the line? And this time I'm thinking probably above the line. So I'm going to choose this point over here. Anything above the line. Yeah, anything. And this point is at -2, 3. So now I'm going to go back and I can substitute it in here, or I can substitute it back in the original. It doesn't matter. I'm going to go back to the original. X is -2 minus 2 times, 3 has to be less than 0. Let's see. -2 minus 6 is less than 0. -2 minus 6 is -8 is less than 0. That's true, which means I'm going to shade everything up here with that point because that was true, which means anything up here will satisfy that inequality. So I could pick 0, 1. I could pick 3, 3. Can I pick 4, 2? And the answer here is no, because this time being on the line is not good because it's dotted. So this would be only if it was equal to. So we can't choose the line, but I could choose -3, -1. I could choose -4, +5, anything in the red shaded part.